A water treatment plant repair in Hawaii shows why EPC execution is not only about big new builds. On July 17, U.S. Army Garrison Hawaii reported a deep well motor replacement at the Area North Water Treatment Plant. AI for EPC looks at this as a process utility recovery problem: access, lifting, water service, temporary constraints and long-term modernization all collide in one asset. The reported milestone was specific. Crews replaced a 4,000-pound, 450 horsepower motor deep beneath the Area North Water Treatment Plant. That is a major equipment package inside an operating water system, not a generic maintenance node. The repair was constrained by geometry. The motor had to move through an 1,150-foot access tunnel on a 30-degree slope to a pump chamber, 575 feet underground. In EPC terms, the access method is not a side detail. It is part of the work package. The underground facility went into operation in October 1938. It includes 4 drilled wells and 1 monitoring well. 2 lower chambers house 4 deep well pumps, each listed at 2,000 gallons per minute, contributing to about 4 million gallons of average daily production. The water issues began July 9, when multiple pump motors failed due to age, heat and a fire in the plant electrical system. The garrison reported conservation measures, while barracks and residential areas continued to receive drinking water and sanitation service. That is the operating plant problem EPC teams have to respect.
A future AI for EPC workflow could treat this repair as a closed loop. First, structure the asset history and failure evidence. Then model access, lifting, electrical isolation, water demand constraints and restart criteria. Finally, compare the executed work against the evidence needed for reliable service. USAG Hawaii said long-term solutions include relocating the deep well pumps to the surface and modernizing the treatment plant. The U.S. Army Corps of Engineers is expected to complete that contracting project by fiscal year 2029 or 2030, while near-term pump and motor replacement continues. The EPC lesson is simple: the next emergency should not start from a blank page. AI for EPC could convert this repair into reusable execution knowledge, equipment data, access limits, temporary service rules, supplier constraints, safety hold points and acceptance evidence. That is how one hard repair becomes a better operating model.